when Todd asked me whether I wanted to do the opening for the day, he said, "Oh, well, whilst you're at it, do you want to do a workshop as well on one of your open source projects?" I thought, "Oh, yeah, that sounds fun. Which one? Which one?" He said, "Oh, anyone you like, your favorite project," which is like asking, a parent which of its favorite children it wants to take to school or whatever. So I couldn't really decide at first, but I decided that actually, because I had the t-shirt, I was going to talk about React, which is one of Facebook's more popular open source projects. It's a JavaScript framework, and it's something that's relatively dear to my heart. So I'm going to spend about 45 minutes talking a little bit about React, some of the philosophy, because it's a little bit unusual in the way that it goes about doing things, and then specifically dropping into a couple of examples. We may even do some live coding, to actually give you a sense of how React works and how you put user interfaces together with the library. So actually, how many of you do have children? All right, lots of parents in the audience. So when they're really young, when they're toddlers, generally the way to get children to do things is to tell them exactly what to do, right? Go into this room, pick up the toothbrush, put it in your mouth, brush back and forwards, you will have clean teeth, then come out again, put your clothes on. And everything that a toddler learns or gets told is basically a set of instructions. As they get older, I've noticed, my kids are now 8, 9 kind of age, and what I find is that doesn't work anymore. They don't want to be micromanaged. They just want to be given broad goals. You sort of say, look, you ought to have good hygiene. You ought to, in the future, aspire to be like this. And obviously, as they mature into adults, it's more and more of this kind of goal-setting approach rather than individual tasks. Implementation details, if you like, are left to the platform. And so with a toddler, what you're embarking upon is a really kind of imperative programming model. And the definition of imperative programming, at least as per Wikipedia, is this. You describe computations in terms of statements that change a program's state. So you write statements and you say, do this, move this, here, they do that, do that, do that. And I'm going to give you strict instructions that I'm pretty sure will end up producing the correct result. Teenagers, on the other hand, deserve declarative programming. In other words, this is what you're trying to get to. I really don't care whether you clean your teeth before you wash your face or wash your face before you clean your teeth. Implementation detail. But I would like you to have good hygiene. And the definition of that in the computer science point of view is you express the logic of a computation without describing the actual flow that it took to get to that end state. So you might be thinking, well, I didn't come here to talk about or listen to parenting advice. I came here to listen to talk about React. And you'll see why this is relevant. But React has some of the same principles in terms of declarative programming that you might apply to a teenager. And maybe I shouldn't use the strapline of ReactJS. It's the teenager of frameworks. But React is a JavaScript framework. It's a JavaScript framework that's designed for building user interfaces. Now, it's been around for about a year. We launched it in May, I think, May last year. To some controversy, actually. People didn't kind of figure out what it was all about at first, because they were so used to an established kind of convention for JavaScript-based libraries. And you might be saying, well, what, another one? React? Why should I deal with this one? And in fact, there are a huge number of libraries out there. You might, go to todomvc.com, for example, which is a website that even lists out a whole host of different JavaScript libraries that are designed almost to the one to produce user interfaces on client-side apps in browsers. And in fact, the way that this site works is that each of the frameworks or each of the libraries produce their own version of basically the same app. It's a little washed out here, but it's a simple app that allows you to add new to-do items and enter some text for them and see how many items are left unchecked. And you go there, and there are maybe 10, 15, 20 different frameworks that have implemented exactly the same app. And the idea being, of course, is that you can look at the code to see how to implement these things differently, and you can choose your poison. But if you're choosing a JavaScript architecture to use for a complex app, is a to-do app really the bar that you ought to be looking at? And if you're building a framework, is a simple to-do app really that big a deal? Is it that hard to do? Well, maybe if you're a company building to-do apps, this is a good place to go and select your framework. But at Facebook, we have to build apps like this. This is our messaging app. We run this in the browser. And you have threads of messages down the left. You have the detail of the thread on the right. We have unread counts up the top. We have a search box. We have a whole host of client-side actions that you can take. We have read and unread threads. We have threads with multiple users in them. We have people joining. We have people leaving. We know which state of whether the message has been read by each member of the conversation in line. And this is all changing like dynamically as people are reading stuff. I mean, it's a highly, highly complex app. It's a little bit more complicated than a to-do app. And obviously we needed to come up with a framework that would allow us to build this kind of client-side application. The thing that the straw that broke the camel's back for us was this little red light up in the top right-hand corner, which tells you how many unread messages you have. And in, 2009, there was a period where the mismatch between that ID, that number of unread messages and the number of actual unread messages over here, it never matched up, and people would report this bug endlessly and by the million. And we had this huge, huge problem with people's distrust of the messaging platform as a whole, simply because we weren't able to keep that DOM element in sync with the DOM elements on the left-hand side. So we knew we had to kind of re-architect the way that we built our complex user interfaces like this, because there is just so much going on. The state is so complex, and the resulting user interface based on that state is so complex that humans just can't reason about how to put something like that together. And this is really important. So a colleague of mine called Stephen Lusher, he has invented this concept of coffee of n. So I'm sure many of you have heard of O of n. It's when you're talking about the complexity of an algorithm or a computation. But coffee of n is like, how many cups of coffee do we have to feed to an engineer for them to be able to figure out how complex user interfaces should be put together? And if you have a user interface like the one I just showed you, where there is a deeply complex data model and there's a deeply complex resulting user interface, and the exponential permutations in between, it is just too much for the human brain to be able to comprehend. And of course, every time you get that wrong, it's the opportunity for a new error to be introduced. So the goal of React as a framework is to always reduce the coffee of n and make it as simple as possible, regardless of how complex the data model is. And so React has these kind of design goals, and one of them is to be as absolutely simple as possible. Another is for it to use a declarative approach. You say how you want the user interface to look, and it'll just get there for you. You don't need to worry about how it did it. And finally, of course, it's open source, so we get a chance to share it with the world and with communities like your own, and hopefully start to see some of these patterns emerging in other apps as the client-side web gets ever more complex. So the basic concept of React is this. It's absurdly simple. For a given state of data, whatever that means, all you have to do as a developer is describe what the resulting user interface should look like. So if in your state you have 2 unread messages, then you just need to describe the fact that the 2 is going to appear up there, and the 2 is going to appear down there, and the 2 is going to appear down there. And whether or not that state has changed or will change, your description will make sure that the right things get into the right place. And you don't need to worry about picking out bits of the DOM yourself and saying, oh, I better remember to change that, and oh, I forgot to change that one down there. Oh. So the idea of React is you just literally declare what the user interface looks like for a given set of data. Now, in a world of traditional client-side JavaScript apps or MVC apps, this kind of seems a bit odd. In fact, it probably seems very naive. I mean, you could argue all computers ultimately do this. But classic MVC client-side JavaScript frameworks, have a lot of kind of complexity between the model and the controller, and between the controller and the view, and then the view back to the controller, or was it that controller, or was it that view? I can't remember. Or do I have to go up and over in the DOM to pick out that little bit of data? You know, it kind of gets a little bit confusing. So this probably seems very simple and very naive, but actually, this is exactly how the classic server-client web worked, right? You had a server, which was the only place that state was stored, some database or some knowledge about the session. And every time the user refreshed the page or went to a new page, the server would completely recreate the user interface, declaratively, I suppose, as HTML, which the browser would then completely render. And every time you ever changed anything, whether it was clicking to another part of the site or entering a form and submitting it, every time you did something as a user, the server would do it all again, completely recreate the user interface, ship it out to the browser flashes white, rebuilds the whole DOM, and puts it up again. So we know, as a web community, we know how to do this. We've been doing it for 20 years or something. Obviously, it's deeply inefficient, right? Because you have to send this, you know, for every single change of state, you have to describe the whole user interface, okay? But it is super simple to reason about. Your server can create the whole user interface exactly as it wants it, and then sends it out, and the browser will just render it, okay? You're not having to pick bits of the DOM and fix it. But as I said, it's very, very slow and inefficient. So what happened with the advent of AJAX and subsequent client-side JavaScript was that people started to get a bit clever, and they started to just like manipulate little bits of the DOM and little bits of the DOM there. And of course, that then gave rise to this kind of complexity. So the reason, or the way in which React is different, is that it still uses this model, but it's doing it all on the client side. So every time a piece of data changes on the client side, React will redescribe, or you as a developer of React, describe the whole user interface again and put it on the screen. Okay? It's all happening on the client. So it's super easy to reason about, super easy to be simple, and it's really easy to make sure that you can keep internal consistency of your app. But I'm sure you're thinking, that sounds absolutely insane. You're rebuilding the DOM every time the user does anything, and the browser is still going to flash, and all my scroll position is going to get lost, and all of my input fields are going to get reset, and all the focusing and scroll position, it's going to be a disaster, okay? And, well, you'd be right if that was what you were doing. If every time the state changed, you recreated the entire DOM, literally writing to the browser's DOM, you know, it would be a performance disaster. Because it turns out that in JavaScript on the client, executing JavaScript is high performance. Actually, you know, the runtimes are pretty amazing at this point. JavaScript runs really, really fast. That is very rarely the bottleneck. The performance bottleneck for browsers is writing, and sometimes absurdly reading, from the DOM. So you're right, this would be a completely insane thing to do. So React doesn't do that. What React actually does is let you, as a developer, describe a virtual DOM. Like, this is what I think I want it to look like. And when the state changes, this is slightly different, but this is how I want it to look like. And what React does, under the covers, as I'm sure you've already figured out, is it figures out the diff of those two virtual DOMs, and it applies just the mutations to the DOM required to get you from that virtual DOM to this virtual DOM, which in this case would be remove that node 3 down and add these 2 nodes on the right-hand side. Now, making single mutations to the DOM is, well, still a bit of a bottleneck, but it's way, way faster and way more efficient than having to recreate literally the whole DOM. So the power, or at least the performance of React, all comes from this describing like a virtual DOM, which then gets mapped onto the real one. This is all pretty abstract at this point. You're probably saying, well, how do you describe a virtual DOM? So this is where I Alt-tab across to MVD number 1, which means minimum viable demo. It is the hello world of React apps. And this is also where I try to figure out whether I can do mirroring on my presentation. Wait, there we go. I might just switch so I can see it in front of me as well. All right. So, this is the minimum viable React app. And, you know, hopefully most of you are kind of relatively familiar with JavaScript, but I'll basically start at the top here and say, look, we are defining a class called label app, which is a React class, And it only has one method, which is the render method. Like, how do I render myself? For a given state, what do I look like? And in this case, it doesn't actually pay any attention to the state of the class. It literally will write out hello world every time. And at the bottom, here is where we are binding this class, this component, into the actual body of the web page. It's as simple as that. So as you can imagine, what this is going to do is run. It's going to mount the component into the web page and render and spit out the content. I'm going to switch across to Chrome and press refresh, and I get the white screen of death. OK, why did I get the white screen of death? Let's pull up the web inspector. There we go. Oh, uncaught syntax error, unexpected token less than. So any of you that are familiar with JavaScript will have said, whoa, 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 what are you doing up here? You can't put angle brackets in JavaScript. You can't start actually writing what looks like raw HTML out as a literal, and you'd be absolutely correct. I should stress this is not the only way to describe the virtual DOM. There is a pure JavaScript way to do it in React, but we actually, in a sister project with React, in conjunction with React, use JSX, which is a kind of an extension to JavaScript that allows us to put DOM elements literally in there like that. Now, what would normally happen is that on the server side, when you're producing and bundling and building your app, you map this to what the actual JavaScript is behind the scenes. But since I'm running it here in a browser, I actually need that transformation to turn this into real JavaScript to happen on the browser. And so to do that, in my index.html, where I'm actually pulling in the JavaScript and pulling in React, I just need to add 2 small lines. One is to say that that script is actually of type text.jsx, and I also need to add in this line, which is a little too big. Let me just shrink that slightly. We also include this transformer, which actually on the client side, in the browser, will turn those angle brackets into the JavaScript that creates the virtual DOM. So I'm not going to have a look at this again, but just trust me. That's running in the background. So back to this app. That now is valid in the sense that it'll get transformed into something that will execute in the browser. I come across here, I hit refresh, and boom, hello world. So that's super, super easy. You can see I'm actually getting a little warning about the fact that I'm using that client-side JSX transformer when, in reality, in production, you would put that on the build step. Anyway, there is our hello world. Now, it's a little unfortunate that it doesn't fit on this screen resolution. Here we go. But in addition to the standard Chrome dev tools that we're running at the bottom here, I've actually installed a Chrome plugin that allows me to see the React virtual DOM in the browser too. This is kind of a little bit of magic that goes on here. But when I switch to this, instead of seeing the HTML that I usually see, I can actually see label app as a node in that tree. Right? That is the element that we defined and that we loaded into the top of the document. And so we can now explore this kind of virtual React DOM in the same way that we would normally explore the regular HTML DOM. And over here on the right, we can start to see more and more data about those individual items. We haven't set anything yet, so it's kind of all empty. So you might say to yourself, well, that's pretty simple. Well, let's see if we can make this do something more interesting. In particular, this label app node that we've introduced, wouldn't it be nice if we could pass in some parameters to that so that it renders differently under certain conditions? And so just like I would do in HTML or in XML, I can add an extra property or extra attribute, and I'm going to do that here. Message equals hello Raleigh. There we go. OK. Now, obviously, when I do that, nothing happens because I haven't actually wired up this incoming property into the state of the app there. So I need to remove this string literal and put in here this dot props. Props is the collection of things that are passed in from those attributes, and put message there. These curly braces at each end are just my way of saying, this is actually like a templating language. This is actually a variable. And so now when I switch back, fingers crossed, there we go. Alrighty, easy. OK, so the parent invoker of the DOM is able to describe some of the parameters that need to be used in the rendering inside. Hopefully that's all making sense. Now, by the way, if I go down and look here in the bottom right, you can see I can actually see that property has been set both up here, but also as a property over on there. Hopefully that's making sense so far. All right. By the way, I've got slides of all this code, and I'll put it all up on speaker deck, so if you haven't been typing along as you go, everything we've done is in there. Okay, so the next thing to talk about is state. We've talked about how you can actually start to describe the user interface, but obviously in a complex app, you're doing that in response to some kind of state. And actually, it turns out that the state of one of these components is made up of two parts. It's made up of the props, which are the things that we pass in as attributes from the parent, and it's made up of its own internal state, which is basically a dictionary, a collection of data that is being managed by the component itself. So props, they're passed in from the parent using the sort of XML attribute syntax, and then once that's done, they can be read, but only read, they're read-only, from inside the component. And you can also set defaults. You can also validate it to make sure that people are passing in the right thing from the parent. Fairly straightforward stuff, strings, integers, booleans, etc. State, on the other hand, is something that is created and managed within the component itself, and it's kind of encapsulated. You can't see it. You're not supposed to get the state of a child looking inside it. It's kind of like just the state within itself. And so the component has a getInitialState function where it basically says, right, I'm going to create this little state for myself. Now, the state that I create may be based on some of the properties I've had passed in, but this is now my state, and I'm going to manage it. So maybe you tell me what the initial message is, but if I choose to change it in the future in response to some user interaction, that's my business. And so there's a this.state, which again is a dictionary, which allows you to read out all of that data. And this is the magic of React. When you ever want to change the state of a component, you use this.setState. Now, because we're not just like writing straight into the dictionary, because we're going via this function, the React framework knows that you've changed the state. And what happens when you change state? You re-render everything. Okay, so you have to use this.state to change the state, but when you do so, React is going to take over and say, time to redraw the interface. And it will basically reconstruct the whole tree, figure out what's changed since the last one, and make the mutations that are required. And it is blazingly fast. It sounds like a really slow, long process, but like I said, the bottleneck with JavaScript on the browser is not JavaScript. It's with the manipulations of the DOM. So all of this happens really, really quickly, and the final mutations that need to be made are super, super fast. Okay, so just to kind of clarify a little bit of the terminology there. Props get passed in from above. State is what the component itself manages. And a component itself, this is the one we looked at before, basically only had a render method. But there are a bunch of other methods that you can have on a component. You can specify what the types of the properties are going to be. You can specify what the default values are. The initial state I mentioned already is where you set the internal state of the component. There are also some lifecycle components like, oh, I'm just about to be mounted into the DOM, or oh, I just got unmounted from the DOM, in case you want to start timers and kill them when you leave and so forth. This is kind of familiar to anyone that's done component-based UI building, maybe even in thick client apps. But there's a whole kind of life cycle of stuff that can happen and you can hook into. We're not actually going to use any of these. Basically, we can do everything, nearly everything we need to today with simply a render function and some details around how we use the data coming in from the parent to create our state. Something that's very important about the render function is that this is getting called every time state gets changed. You do not change state inside it. Okay, you are only reading properties and state in order to decide what to render. So this is what we call a pure function. If you called render 1,000 times, you should get exactly the same DOM or virtual DOM description every single time, unless the props and state have changed, in which case it might be a different DOM. Okay, so this is only very much a sort of a read-only function. Now, in terms of responding to user interactions, I mean, we're in a browser, so you do hook into the browser eventing system, looking for clicks and mouse movements and scrolls and so forth. We actually have a sort of a synthetic layer above that for some browser compatibility, but it shares the same names that you're used to if you've used pure HTML, so things like onClick, onChange, etc., etc. And the handler that we passed in there can, of course, be a reference to some other thing in the component. So this is a component that responds to being clicked and then does something when it's clicked. Super, super easy, right? But one of the interesting things is that callback doesn't need to be a function on the component itself. It could be a function passed in from a parent. Okay, and the parent is basically saying, right, I'm going to create this DOM underneath me, and if that thing ever changes, I need to be told about it, because it might affect something else on the other side of the web page or down at the bottom down there. So this can be a sort of a deep kind of callback right up to the point, like some sort of high-level component that has responsibility for pages or parts of the other parts of the page. Okay, we'll do this in a little demo and make it a little easier, perhaps, to understand. For those of you that need to see code, let's do it. So we have same demo. What I'm now going to try and do is see whether we can, tell you what, firstly see whether we can default the message. So one thing that we can do is get default props up here, and this is a function. And you always need to put the little comma after that. It's easy to forget. This is basically going to say, if I don't get properties turned in, passed into me from my parent, what properties do I need to have? And we definitely need to have a property called message. And yeah, maybe by default it should say hello world. Okay. Now, in theory, I can now take that property off, and it should still say hello world. I hope I got that right. Let's just check. Yep, great. So it's kind of a contract between the parent and the child. The child will render it if that optional property is left off. Now, what would be quite cool is if I could get that message to change in response to actually doing something on this component. So I'm now going to add a click handler. Let's just do this. Is it easy enough for you to see? On click equals, and maybe we'll do this on click, and then we'll have another little method in here called on click, which is what is going to happen when we click the label. It's kind of easy, right? Now, what am I going to do when the user clicks on this? I want to change the message, so I actually want to change what gets rendered out here. But this was a property, and remember, properties are read-only, so I can't actually set that property. That was what got passed to me. What I can only change is my own state. So what I want to do is something like, well, firstly, I want to create a state that contains that message. So I'm going to do get initial state. And that is going to have message. Whoops, I need to return that as a return. And we're going to have the message. And the message that we return, doesn't need to be a string, here is this .props.message. And down here, we're showing state. So let me just cover that quickly. So when the component fires up, it gets its initial state, and it decides to create a state which has also an entry called message, which is whatever was passed in from the parent. So to start off with, it'll take what was passed in from the parent, or in our case, whatever the default was. But when we click, now we can actually change that state, and I've now switched this to be the state down the bottom, so it's what the value in the state was, rather than the value in the props. So in the onClick, all I need to do is this set state to be, we're going to set the message to be hello, right. Oops, important stuff. All right. right? So hopefully that's fairly self-explanatory. But the point here again is that when I do the set state, it's going to force this render method to be called again. And so it'll write out a new value into the real DOM. And assuming I got all the commas, that actually doesn't matter. I do need a semicolon there, arguably. I'll take that off. I think trading commas in dictionaries work. Okay, so there we go. And when I click on it, boom, 8 changes. Hurrah. But what's also interesting is that when I select on here, you can see in the bottom right in our little DevTools thing here, the original message that got passed in is hello world, but the message that we're now displaying, the state, that since I clicked it, got set to be hello Raleigh. And the HTML DOM got updated accordingly. Now, just whilst we're here, something that might be of interest to any of you that know a bit about HTML events is that when I go and look at the real, what is the iframe doing there? Go away. What actually happens, of course, is that a DOM event is being attached to this element. But what we do automatically is aggregate those all right up to the top and kind of handle them all at the top of the DOM. So in fact, if you go and look at the event listeners for this div, you'll see, yes, there is our click handler that we responded to, but actually that's sitting right up on the document. So even if you have like hundreds or thousands of bits of the DOM that are all waiting for clicks, you don't actually have separate handlers for every single one of those. They're all getting aggregated up to the top and handled there. And of course, that event handler at the top does know which one actually generated it, but you're obviously being a bit more performant because you've got just the one handler up the top. And you don't need to worry about destroying them and all the rest of it. Small aside there. All right, switch back to here. And so you might be thinking, that's all very good. Don't want to build an app which just changes hello world to hello Raleigh. That's not even as complicated as a to-do app. So let's talk a little bit about how data flows in far more complex apps. So basically, we only created a singleton there, a single component on the page. But obviously, in a regular web app, you've got a tree of these components. You've got, maybe rows of or records of a data table. You've got the data table itself, maybe some panel off to the left-hand side, and you've got like the overall app that owns the whole thing. And each one of these could be modeled with a different React component, each of which was passing down props to its child when it declaratively said what they're going to be. And these props get all the way down to the bottom. And then when we set state by pressing a button, we were modifying the state of that component right way down the bottom. Well, that's fine, but if you were building, let's say, some master row detail kind of app, you would want the row component, when someone clicked on it, to send a message that the panel off to the right now needs to change to show something different. Or in the case of our messages app, if you click the thread list on the left, you would want the thread on the right to be the one that you just clicked on. So how do you coordinate changes in state between peer components or parent-child components? And obviously you can't do that if all you're able to do is set your own state. So what happens is that actually the component that's right up at the top that needs to know about all of these changes passes its callback all the way down to the bottom. And so when that component change happens, it's calling back right up to the top. And it's the component at the top that is changing state. And you might say, well, that kind of seems absurd that things are happening down here but changing state up there. But actually, it's kind of an elegant flow. You've got this unidirectional data flow. The state of the application is all stored as high as it needs to be in order to coordinate all the related children. And it passes down all the event handlers it needs to the bottom, and then the callbacks will go back up to the top. So in fact, you have this loop. You never have components trying to influence each other. You never have component X trying to remember to update component Y. And then when you come and add a new feature, remembering it to update component Z as well. So the idea here is that the master, which is obviously the one that's been responsible for putting the whole UI together anyway, knows which ones need to change and which ones need to be redeclared according to the data that's changed. And this unidirectional flow is kind of powerful, actually, when you think about it. Again, it seems really naive, but if you give it 5 minutes and think about it, you go, actually, that makes a lot of sense. And we have a sister project to React called Flux, where we've actually tried to codify more of this unidirectional data flow with a dispatcher that sits up the top to help drive data only in the right direction. Because quite honestly, if any of you have ever tried to build synchronization software where you have two systems and you're trying to keep them bidirectionally synced, you'll know it's phenomenally hard, a lot harder than you'd think it would be. And in this case, it's n-directional sync, because in theory you have 1,000 different components all needing to communicate with their peers. But by doing this, you've got unidirectional data flow, and it's so much easier to reason about. And it turns out that the performance you might think you would lose through doing this is totally mitigated by the use of the virtual DOM. So as a general principle, when building React apps, you move the state, in other words, I guess the data that's describing the UI, as high up the tree as it needs to be in order to dictate any affected children. So as a very concrete example, imagine if you did have, let's say, a very basic spreadsheet app running in your browser. So it's a table comprised of rows, comprised of cells. And let's say each cell has a numeric value in it, and you're allowed to change those values, or every time you click on it, the value increments, or I don't know, whatever the thing does. If that was all that this app did, you would be able to store the state of the value that gets displayed on the cell itself. Because if you change the value in the cell, yeah, no big deal. Like, it doesn't need to tell any of its peers. It doesn't need to tell any of its parents or grandparents that that piece of data has changed. So you can have state right down at the bottom. Let's say you wanted to add a total cell at the end of each row, like that. Well, now, if you change the state of a cell down here, if you enter a new value, you don't need to communicate with your peers here and here, but you do need to communicate somehow to get the total cell updated. So a change over here has updated this. So now the state should live on the row. And it should be the row that is basically now keeping an array of these values and passing the value down to each cell and passing the total down to the total. And of course, finally, if you were to have a row at the bottom that was giving you the total of columns, you would actually have to store the state, that is the grid of data, the matrix of data, up on the table itself, because that is the only place that is common to all of the elements that need to be updated whenever an event is fired on one of these individual cells. I hope that makes sense. I hope it makes sense, because now we're actually going to build that app. But I'm not going to type it in because it's a little bit longer, and I'm going to show you some of the code to do it. So this is actually, I'm basically going to walk through the code that you would use to create that app. It's a n by n or n by m grid with totals at the end of the rows, totals at the bottom of the columns, and totals in the bottom right-hand corner. You change the value of any of the cells, the totals all recalculate. Sounds very, very simple. We've used spreadsheets for decades, but actually doing that in a browser is kind of a tricky thing because, I've got to remember which cell I was in and which row I need to update, and then I better read from the DOM all my neighbors to add up the total, and what a headache that would be. So what we're going to try and do is do that with React and see how easy it is and how easy it is to reason about what's going on. So here we're creating the very parent class first, or the component, which is the table. The initial state is literally, unnecessarily verbose, literally just an array of arrays. So we have a number of rows that have been passed in. We're getting that passed in by the parent. So we're saying, like, give me a table of n rows and m columns. And this basically is looping around, and it's setting the data for each of those, initializing it to 0, and returning the state of this array of arrays. So it's much scarier than it looks. It's just literally a loop over a loop. And then we have a render function, and all that render function does is return an HTML table with some stuff in, which we'll put in a moment. And to initiate the entire app, to bootstrap the entire app, we're just using the React render table, and we're passing in the number of columns we want and the number of rows we want. Let's say 4 and 3. And the final argument on the end, which I ran out of space to put in, is the DOM element that we want to attach the table into. Okay, within that we have rows. So a row is, again, another class. This is a super, super simple one, though, because it doesn't have any state of its own. All it does is wrap its children, which are going to be cells, wrap its children in a tr. So that's a pretty thin proxy component just to basically contain a bunch of cell children. Doesn't do anything else. And we have a total cell, which is the one that appears at the end, which is, again, super, super simple. All it does is display a value that is passed into it by its parent. Okay, puts it in a TH, so it has slightly different formatting or whatever. All right, so those two components, done. Super, super simple. Pretty easy to reason about those, right? And then cell, which is the one where a user can actually make a change. It's a little bit more complicated, but again, it basically just has two functions. One is the render function, where it writes out a TD. My indenting's gone a bit off there, but anyway, it renders out a TD containing an input box, and I've just used the HTML input type equals number field so that it's constrained to numbers, and all it does is display the value that was passed into it from the parent, and has this event listener. So when the user changes a value, something's going to have to happen. And what it's going to do is fire this onChange event, which is basically just a wrap around a change that has been passed in from my parent. So this is the way in which the table, right up at the top of the tree, is passing down through the props to the cell, like, if your value ever changes, you better let me know, because I'm going to want to have to redraw the whole table. And so that's what it's doing. And it's also just making sure it passes back up what row it was in, what column it was in, so we know which cell it was, and obviously what the value was that the user just typed in. So that's the cell. Again, the cell class, not particularly difficult to reason about. And we're done, actually. There's one final piece, of course, which is what do we actually render in the table. And so basically, I've pseudocoded this slightly, but the table rendering is for every row, produce a row containing some cells, and for every row, add an extra value on the end. And when we write out the cells, just make sure we remember to pass in our event listener, so that if it ever changes, let us know, and give me the chance to update my own internal state with whatever the value is that's changed, and make sure that I write that changed value back out again. Okay, so in the actual code, this is a little bit more verbose because we have to do loops over loops, and I needed to fit it on the slide. But that is basically it. So we decomposed the UI into these elements. We figured out that the state needs to go right up the top, and listening to it for event changes that happen right up the top, and then we just write everything out. And as if by magic, I'm not going to type all that in, but I do have one ready to go. So if I just change that to Boxes app, here we go. It's like 85 lines of code, and most of that is just in the render function looping around to write out all the rows. And in the browser, boom, here we go. So here we go. There is, let me just come across to the React view of the world. So here is our table with 4 columns and 3 rows. Inside the table, there is actually an HTML table which contains our row components, and inside there we have our cell components, each with their values, and which row and which column they're in. And then inside of those, there is the HTML for the input box, the HTML5 number input box. So that's kind of scary when you see it written out like that, but trust me, it's super simple. But the point is now that, just make sure I can see the whole thing here. Each one of these is now a field, and if I change, everything gets updated instantly. So what is happening every time I change a number down here is that is calling the callback that the table is waiting for. The table redraws the whole of itself, which seems super scary. But actually, the diff algorithm will then figure out that, wait a minute, when I changed that one, the only 2 things I needed to update were the value over here and the value down here. Those are the only 2 DOM mutations that actually needed to happen. I, as a developer, haven't had to say that, okay? But the React DOM diff has figured that out for me. Okay, and just in terms of performance, I guess, just in case any of you are a little worried about how long this takes, let me just spin up, let's say, 100 columns and 100 rows. Any of you that know anything about browser DOMs are probably a little scared at this point. There we go. So we now have a table. It's not very good on a screen like this, but we have 100 rows and 100 columns. Let me scroll right over to the right here. And if I edit this, it's not quite instant. I may be waiting half a second at most. So, at some point it becomes pretty difficult to maintain 10, like 130, 260,000 DOM nodes. But anyway, it's doing it relatively quickly. This is far from painful to use. Okay, so I've obviously taken it to an absurd limit here, but you can see that even when it's a very, very, very large DOM, when I make a change, React is smart enough to know that only 2 bits of this huge DOM actually needed to get changed. And what I could even do, just to kind of complete the point here, let's just take that cell there and make it red. Okay, and I'm going to change, where's it gone? And I'm going to change one of the neighboring cells to be 6. And nothing happened to the red, right? React didn't know that I'd updated that in the browser, right? It knows that does not need to be updated, so that hasn't been redrawn. The only one that got redrawn was the one off to the right and the one that's way off to the bottom there. Okay, so there it was. Let's just finish off quickly. And again, I put all the code and the screenshots in the deck, which I'll share on Speaker Deck, so you can check it out later. So just to summarize, I'm pretty much done for time. There are basically 3 important concepts that I think you need to take away when you're working with React and thinking about React and reasoning about what it means, thinking in a Reactful way. One is that it's entirely a component-based UI. In fact, the only thing you can do in React is build components. That's all you do. Describe their small set of functions, how to handle state, and how to render themselves. You have this concept of a virtual DOM that does all the heavy lifting for you, takes your declaration and turns it into a set of imperative mutations that get applied to the DOM, and it's super, super fast. And finally, this concept of unidirectional data flow. Make sure that your data is just going around in one direction. Don't start trying to get data going up and across and sideways, because you will introduce bugs. If you can keep it unidirectional, it's so much easier to reason about. If you're still not convinced, honestly, the thing to do is just try it out. It might seem a bit odd at first, especially the JSX syntax. You're thinking, oh, angled brackets in JavaScript. But trust me, try it out. Give it 5 minutes. Get a little bit more familiar with some of the concepts. I will post this up, and there's code, obviously, in all the slides here. And the website is reactjs.org. There's a super helpful community that goes with this. It's really, really popular at the moment. We have a lot of external contributors. We have a lot of fantastic plans for the future. And we've just gone to release candidate for 0.12 of React. We are nearing the 1.0 release, so very exciting times for React. And what can I say? Lots of people have tried it. Lots of people have enjoyed it. And I hope you get a chance to kick the tires too. Thanks very much.